So for question 4, we're looking at a Hungarian algorithm question where we have got some siblings in the same family doing weekly chores, and these chores are taking them a certain amount of minutes in this case. So part A is for us to interpret that 19 that's shaded in the table. And so it is under Bobby, it is under folding laundry, and then we know that our units are in minutes in this case, so we should be ticking box 3. It says, based on the information in the table above, which child is the fastest to complete the dusting? Okay, so we're looking down here and we can see that it's going to be, who is it, Joe, that only takes 15 minutes to do dusting. Part C, calculate the total time it would take Kelly to complete all 4 weekly chores. So we're looking through here, and it's going to be 23 plus the 17 plus the 20 plus the 16. 23 plus 17. Did I enter that right? Okay, so it's going to be 76 minutes. Okay, next page, we actually get to start the algorithm. So it says we want to minimize the total time spent on these weekly chores to show that the result in each, and show the results, in each step clearly. Okay, so it's a minimization problem, so that's important for us to identify right from the start, which means that they've started off the Hungarian algorithm, and our first step is to do a row reduction. Actually, I might just move that a little bit closer just in case I need it. So row reduction. So when we do a row reduction, we're looking down each of the rows, we're finding the smallest number, and that's what we're going to subtract from each row. So I'm going to take 16 from the first row, 18 for the next row, and then what's the number? The next smallest is 15. Okay. So subtracting 16, I'm going to get 7, 1, 4, and then that 0, which is what I'm searching for here by doing a row reduction. 16 on the next row is I'm getting 11, 5, 8, and 0. Next row, I'm subtracting 18 to get 7, 1, 3, and another 0. And then my last row is going to be 10, 3, 7, and then 0. I just tie up my brackets. Okay. Next one is going to be a column reduction. A similar idea, but now we're going to go down each column, find the smallest number. Whoops, reduction, and then subtract that from each element in that column. So I've got a 7 here, which I'm going to subtract. I've got a 1, is that a 3? And then we don't do anything to that last column. Okay. So going down now, so it's going to be 7 is going to be 0. We've got a 4, 0, and a 3. Another 0, a 4, a 0, and a 2. 1, 5, 0, and a 4, and then there was no change to that last one. So we've done that column reduction and the row reduction. So now we're going to be looking through to cover up our zeros, and we want to cover the most amount of zeros in the least amount of lines, horizontal and vertical lines. So that one is obviously going to be where we're going to start. We can also cover 2 on this row and 2 on this row with a line, and that's all our zeros covered, but it means that we have 3 lines but 4 rows. And for a Hungarian algorithm to stop, we need the four the same amount of lines, the same amount of rows. So we need to then go searching, and we are going to look for the smallest number that's not covered up, which in this case is a 2. And it means that we are going to plus 2 and -2. So we'll start with -2 from all the elements that are not covered, and then +2 from the others. Okay, so let us start looking through here. So anything that's got a double 2 lines through it, we're going to add 2. So we're going to add 2 to the top corner here, and then down there. And then the ones that just have a single line through it, nothing changes. So my top line here stays as 0, 0, 1, where I've already modified that last element. My other line that's covered is the 0, 0, 0, so nothing changes there apart from that last element on that row. And then all the others I'm going to -2 from. So it's going to be 2, 2, 3. My 0 doesn't change because it's only got a single line. And then on my last line, I'm going to have 1, 0, 2, and then that last element has changed. Let me just fix my brackets. Okay, so once that's done, we try to do our lines again. I've got 3 through here that I want to try to cover up. I've got 2 on this row, 2 on this row, but then I've got my last one coming down there. So now when I look at this, I've got 4 lines and I've got 4 rows. So that means I'm ready to do my allocation. Now there's a couple of ways that we can do the allocation, and I'm going to do both. Just so again, I know a few of you prefer each of the methods. So I'm going to bring down my matrix above, or I could bring down my original if I wanted, but I think I'll just stick to okay. Now, because I am doing the allocation, I'm going to go around the outside of the matrix and just at least put the names there of the siblings, or the initials, sorry, of the siblings, just so I can kind of think about which person is being allocated. And then just the initials again. So ironing, we had folding, and then was it vacuuming and dusting was the last one. Okay, so that just helps me as I go through. I might keep it as red. Okay, now we're looking for anyone that only has 1, 0 on a particular row, or doesn't matter, it could be column. In this case, we're going to allocate Paula to the dusting as a 0, and then anyone else that had a 0 on the dusting, we're just going to put a cross through. Because I did just cross out Joe doing dusting, it means that he now has to do the folding, because that's his only allocation with a 0 on it. And so that means that Kelly can't do the folding. So her only option then is to do the ironing. And if she does the ironing, then Bobby can't do the ironing. Oops, I should have crawled off the folding before from him. And that means that his only option is then to do the vacuuming. So if I'm going to make a summary of that somewhere, I'm going to say, well, Kelly does the ironing. I'm going to say that Paula is going to do the dusting. I'm going to say that Bobby is going to do the vacuuming. And then Joe is going to do the folding. Now, that's one way to do it, but for those of you who like the bipartite graph method, we can do that off to the side as well. So again, I'll just write down all the initial, I might leave a bit of a space, all the initials of the siblings first, and then their jobs off to the side as well. And then I'm going to go back to my matrix, and I'm going to put a 0 connecting any of the jobs that they could be allocated. So for instance, whoops, this one should have been a K at the start. So K can go to the ironing, but could also do the folding. P can go to down here to the dusting. Bobby had a lot of arrows, so they could go up to the ironing, they could go to the folding, but also to the vacuuming. And then J could go up to the folding as well. and then also then across to the dusting. And you essentially do the same thing that we did before. I don't know if my highlighter is going to work here. Okay, so there's we're going to look for ones that only got one arrow coming out of it. So that's going to start with down here. Okay, and then that means that we cross off anything else that also points, or any person that points to D. So we can cross off that one. Now when we do that, we can see that J comes up and does the folding, and then anything else that's going to the folding we are going to cross off. Which leaves us with the two choices above. There's only one that's left that's going to the vacuuming, so Bobby has to do the vacuuming, which means that if he's doing the vacuuming, he can't come up here and do the ironing as well, so that Kelly goes and does the ironing. So it's the same allocation that we had before. Okay. Oops. So now we're going to go down and have a look at what's happening here with actual putting our final answers in. And it's just writing what we've just done above. So we're going to do ironing. For Kelly, the dusting. Bobby is going to do vacuuming. Oops, spelled that wrong. No, I didn't. Vacuuming. And folding. And we want to know what that minimum completion time is. So we've got to go back to the original table above, and on the previous page, are we seeing that for Kelly to do the ironing, it's going to take her 23 minutes. Paula to do the dusting, it'll be 16. The vacuuming for Bobby will be 21, and the 18. And let's see what that adds up to. So 23 plus 16 plus 21 plus 18 is going to be 78 minutes. Okay, remember, always think about your units as you go through. So we're going to now flip over to the next page, and there's going to be a big change here. So this time the children's father said that they will do one of the weekly chores. Very generous. And as a result of this change, a new initial array has been produced. Okay, because he's obviously he's taking, for instance, 20 minutes to do the ironing, 12 minutes to do the dusting, etc. Okay, so it says, why is a dummy column of zeros now be added in order for the Hungarian algorithm to be applied? So just something along the lines of that, the number of rows must equal the number of columns, or you could say you need a square matrix. That's why we need the other zeros. So in the background somewhere they've done those zeros, they've come out, and then this is the result below of what we get. And now we're going to be thinking about doing that allocation. It probably doesn't hurt us to just think about what these headings are. So we're doing ironing, folding, vacuuming, the dusting, and then remember this last one was now going to be no task. Okay, so when we go to allocate here, I'm looking along my rows. I can see that there's only 1 0. I might just change my pen color. There's only 1 0 here. Which means that I think it was Kelly was the first person, is allocated to the folding. If they do the folding, then no one else can do the folding, so we can cross those out. And we look across our rows again. This gives us that the dusting is done by this person here, and if they have to do the dusting, then the second person and the father cannot do the dusting as well. Still looking across to finish off our allocation here. The second person, which I think was Paula, has only got 1 0 left, which means that they're actually going to get no task. And so anyone else that had a 0 under no task cannot do that one. So that means this person, I think it was Bobby, is doing the vacuuming. The dad can't do the vacuuming, so the dad is left with the ironing in this case. So when we're looking along our list, it says state the member of the, the question F, state the member of the household who will not be allocated a weekly chore. Well, that's the one on the second one, which I think was Paula. So I've just pre-filled some answers here, but you only need 2 of them. So we can, there's obviously a lot more that you could write, but it could be something like saying that, for instance, the last dot point, the child may not be terribly good at doing the task. So even though they do it and get allocated it, they may be absolutely worse at it. And so maybe the dad would be better off doing that task. Someone who gets the longest amount of time, not really fair. There could be a little sibling rivalry there. They have to take, that takes them longer to do their weekly chores, etc., etc. So lots of different options there. These are just 4, but you need to write down 2 when you're doing this question. So in question 5, we've got the scenario of someone taking out a home loan of $650,000, and it's going to be over a 20-year time frame. The first question is to show the minimum monthly repayment is going to be equal to the $3,570, or approximately that. So we're going to have to write down what we're going to put into our calculators first. So we're going through, it is going to be a compounded monthly, so our PY and CY will be 12, and it's for 20 years. So we're going to do the 20 times 12. At the top for the number of compounding periods, it's going to be at an interest rate of 2.88%. Now our PV here, because it's a loan, has to be positive, so it's going to be $650,000. The payment is what we're going to try to find, hopefully around that 3,570 mark. And because it's a loan, again, we're going to have a future value of 0 because we want to have to pay off the whole thing at the end of the 20 years. So going to our calculator to enter that, we're going to go into apps. We've got our finance, which is number 1, and that TVM solver also number 1. It's going to be the 20, whoops, that is, that's going to be 20 times 12. Up here, it's the 2.88%, 650,000 is the amount of the loan. We're going to solve for our payment, so we can 0 that off. The future value will be 0, and then we're compounding monthly, so PY and CY is 12. Go back up for our cursor over payment, and we're going to alpha solve that, and you can see here that we get the negative 3,565.96298. Now we have to decide what to do with all these numbers because it is a payment. We like to round it up, so therefore our payment is equal to 3,565.97, okay, and then which is approximately, we can say, is equal to 3,570, or we should put that in dollars, I guess. And it's important, again, because it's a show that question, that we always put this first before we then go and say that it's approximately equal to the 3,570. So we come down to the next one. It says calculate the total interest that will be charged over the 20 years. There's a couple of ways we can do this, and I will do it both ways. So we can say that the interest is equal to our payment times n minus our PV. In this case, it's going to be the 3,565.97. We had 240 payments because that's 20 times 12. And then our PV was 650,000. Oops, yeah, that's right. I don't know. Oh, we can do it in here. 3,565.97 times the 240 periods, and then take 650,000. And we have 205,832.80, so $205,832.80. That's one way we could do it, or the other way is just us doing our sum of int using our command on our calculator, and that's 1 and the 240. So we have to make sure that we've got our right payments in here. So we said that that was equal to negative 3,565.97. Everything should be fine there. So just quit. We need to come out to this screen first, and then we go back to apps. We go finance, and we're going to scroll down to the sum of int, which is the sum of our interest, and then 1, 240. So starting at 1, going up to 240th repayment, and we get this time that it's equal to 205,830.52. So either of these methods would be correct. Another option is, and sometimes people do this, is you could use the one that we were trying to find it approximately equal to, so 3570, but I always tend to use or prefer to use the actual value that we calculated as our payment, not the approximate value, and that's what I'll continue using below. So we get to after 5 years, the balance is now at 520,700, and the interest rate increases, and we've got now 3.6% per annum, and it's compounding monthly. So we're going to do a few calculations in part B because we want to maintain her repayments, but how much longer is it going to take her now to repay the loan now that the interest rates have actually changed? So how much longer is the N we're trying to find. The PY is still compounding monthly. The interest rate is now at 3.6%. We've got 520,700 on this loan. The repayments are going to be the 3,565 how many cents was it? 97. The future value is still 0 because we still want to repay the loan. And we're going to see how that goes. Okay, so we're going apps, we're going to finance, TVM solver. N is what we're trying to find, so I'll just zero it off for now. We've gone up to 3.6% interest. The loan is now at 520,700. Those repayments are fine. The future value is fine. Okay, so we get here that N is 192.41 months. Now we want to know how much longer it's going to take, so how much extra. So therefore it takes extra. We'll start with the 193 minus, we've already had 5 years at this point, so the amount of loan left otherwise would have been 15 if we didn't make the changes. 15 times 12. Let me just 193 take 15 times 12. So it's an extra, that's not right. Let me just, 193. Oh, that's 93 take 15 times 12. That's better. Take 13 months. So it's going to take an extra 13. Now I'll just take note here. The thing that's maybe confusing is that 15. It was a 20-year loan, but this is we've started at the 5-year mark, so there's only 15 years left of the original loan, but this is the change loan. Okay, last little bit of this question. Let me just change my pen. We're going to do this lump sum payment now, and so we want to know what size of the lump sum is going to be needed in order to repay the loan in the remaining 15 years. So we've got the 15 times 12 because it's monthly. We'll put the 12 down the PY and CY. The interest rate is at this 3.6 level. We're going to be finding that amount, and we're still going to be working with 3,565.97 as our payments. So let me just put this back to 15 times 12 up here, 3.6. I might just zero that off and go through and check everything else. Okay, so we're only really just solving for PV. And we're going to write down that that's now 495408.89, which given that means that our lump sum is equal to, let me just get that, oh, you can't see it. Oh yes, you can. So it's 520,700 minus this amount that we've got here. So minus the 495408.89. And so we need a lump sum of, I might just do it out in this bit, 520,700. So we need a lump sum of this amount, so 25,291.11. And so that will mean that we'll be able to repay the loan in the 15 years if the interest rates are going to go up. So in question 6, we are looking at some linear regression, and we're looking at how the area of the Arctic sea ice has changed from 1980 to 2020. So it's saying, using the correct variables, what is the equation of this least squares regression line? So we need to go into our calculators and enter the data. So you're going to go press your stat button. You want to go number 1 and you want to edit it. Whatever data is there at the moment, just give it a clear, or you can start a new list if that's what you want to do. Okay, so once the data's gone, you are good to go. So you're going to go 1980, 1985. Oops. So I've just gone ahead and entered the rest of those numbers from the table. So always double check your numbers after you've entered it. Don't want to get to the end and then realize that there was a mistake and have to redo everything. So once you've entered your data, you're just going to go back to your stat one. You're going to go across this time to calc, and you want to go to where it says linear regression AX plus B. You can just press number 4 to go there directly. We entered our data in list 1 and list 2, so just make sure that they've been done correctly. And then we're just going to go down, and we'll just go down and calculate. And you can see there that you get your A and B values that you're going to put for your equation below. Now, what you have to look out for here is it's saying using correct variables. So it doesn't want you to use your Y and your X. It wants you to use up here your D and your S as your variable. So you are going to have that S is equal to, and your A value in this case is negative 0.082. So we'll use 3 significant figures. It's going to be times by that D value. And then this time the B value is going to plus that 169.6. 28. You could actually, we might go back. We might only have 2 decimal places for this one. We needed the significant figures in the previous bit. And that's enough. So for 2 marks, you're going to use the correct variables, and you're going to grab those values from your calculators, the A and the B. Now, you're going to come down here, and it's also asking you to have a think about your R value and then what that actually means. So in our case, we've got an R value of negative 0.979, and what it's in the sentence below, it says this suggests that the, and you've got to put in the right variable here. Let me just move it so I can actually see my variables. So it's going to say the year of observation. I'm going to have to write tiny to fit it in. You can also write D if you want. As the year of observation increases, the area of Arctic SACE or the S variable will, and it's going to decrease because of that negative correlation. Okay, now they've gone and found the residuals for us, although you can see here that something is obviously amiss and we probably have to do that on the next page. They've graphed those residuals for us to have a look, and then the first question we say is we've actually now got to find that missing value from that table. So you can think of it in terms of your predicted value and your actual value. Is it how you calculate your residual? So you've got predicted value, and that's equal to, using our equation, so negative 0.082. It was in the year 2000 that we had the missing value, plus the 169, and I think we're going to use 2 decimal places, 0.63. And we'll see what that equals, 0.082. 2000, and then we want to plus 169.63, and we get that it's equal to 5.63. Now that's the predicted value, but then to get the residual, that's going to equal our actual value, which from the table is going to be 5.76, and we're going to take away that predicted, so the 5.63. 5.76 take 5.63, and it's equal to 0.13. And then it says plot the point A, so we're looking for that 0.13 at 2000. So it's going to be just below 0.15, so somewhere along that line there. It does say mark it as the point A, so we will put A on the graph. Then we're going to use that to actually predict what's happening. Now, this 1 million here, that's going to be equal to our S value. So S in this case is going to equal 1. And we're going to substitute that into our regression line. So 1 is equal to negative 0.082 times our D value, plus the 169.63. And when we rearrange that equation, we get 1 minus 169.63, and then divide it by negative 0.082, and that's going to equal 2056. So it says predict the year. So it's going to say therefore in 2056. We're going to expect that area of Arctic sea ice to be 1 million kilometres squared. And yeah, because it says in the year, we do need that integer solution there. Just for the last little bit, I've just pre-filled it for us just to save some time, but it says discuss the reliability of the prediction that you've just done and give 2 reasons for your answer. So what happened here is we've got the data, we've got it coming out to 2056, but when we go back to our table, but our table was only went up to 2020, so we've extrapolated quite a lot. Having said that, though, if we have a look at our R value, we've got an R value of negative 0.979, and I think, hang on, I should still have it here somewhere, calculate number 4. If we just quickly look at our R squared value is 0.96, so they're actually quite high as well. So even though we're extrapolating a long way, we've got, I'm going to say here, a strong R squared value, and the random scatter on the residual plot is also showing that the linear line is appropriate. So prediction is reliable. However, we can then go and say we are extrapolating 36 years from the known data, so there's no guarantee that a linear trend will continue that far. So that's us discussing the reliability. Yes, it's reliable because of high R-squared value and the random scatter on the residual plot, but we are extrapolating a long way, which lends some doubt to it. I've written in red that you could also argue against the reliability, with saying your two reasons could be because of the extrapolation, but also you could mention about how global warming is going to affect things as well. But the blue answer is probably the one you want to go for here.